resistance inductance, he has given these drops: 60 volt, 40 volt, and 40 volt. Yes, we can solve even any circuit we can solve. Let me come in order. At what angular frequency of the source, the current in circuit will lag behind the source voltage by pi by 4. Current will lag behind. So what the circuit should become? When the angular frequency is how much it is? Now omega 1, let me call this 4 into 10 to the power of 5. These are the drops here. So shall we go for making a guess of VRMS? It's not given. So this is what VR, this is VL, this VC. So according to the formula just now, VRMS square is equal to VR square plus VL minus VC whole square. VRMS square we don't know. VR is 60 square. VL is how much? 40 minus 40. Yes, some information. I'm trying to gather what all information I do have. Then with this, I know the resistance are 120 ohm. I'll get the current. I'll call this is current I1. So across the resistor, VR is equal to I1 into R. VR is how much? Given 60. I1 resistance is 120. I1 is equal to 0.5 ampere. But the question is something is being asked. No? I know I1. So can I get XL and XC value? XL and XC value. Yes, we can get the XL and XC value. Applying VL is equal to I1 into XL. VL is 40. I1 is 0.5. VC equal to I1 into XC. I think it will be same. 80 ohm. After knowing XL, can we bring L value? Yes, we can calculate L value. XL is equal to omega L. And we know omega value. Substituting will get the value of L. Similarly, XC is equal to 1 by omega C. C is equal to 1 by 80 omega. Let's have XL value we know. So XC value also we know it. And next again, at what angular frequency of the source the current in circuit will lag behind. Directly what is given is going to give us the phase angle. Lag means what happened? It should become effective. XL should become greater than XC. According to the data, I'm rounding off this like this. Oh. Try to see this one. This sentence with this what I conclude here. Now you XL must be greater than XC. Then only it will become lag circuit. No? If XL equal to XC, then it will become pure resistive circuit. You look at the drop across the inductor, 40 volt, 40 volt. It has become pure resistive circuit here. What is the power factor of circuit? It is the unity. What is the high and VRMS? They are in phase. So what is the power factor? It's equal to 1 in fact here. Now what you should make now? You should make it a lag circuit here. Now it's a pure resistive circuit. Sir, already inductor, capacitor there's a drop across that. Still you are saying pure resistor. XL and XC, they'll be equal and opposite. You do one thing, you calculate XL equal to XC, what we are getting. XL equal to XI, and they'll be equal and opposite. So the power factor is unity. Now what is asking us? The power factor should not be unity. It should become, now XL should become greater than XC. What is that angular frequency is asking? So I'll take help of this one. So the circuit will be now, there's a background. What we have done is a background. Now I'll enter into the question. So there is a, I'm not going to change the value of L and C. L and C are as it is. Now I'm going to vary the frequency, omega 2. A new current will flow, I2. Now this will be VL. This will be VC. And this is VR. Some other values. Now what is the basic condition here? VL2 will be greater than VC2. Then only it will become a lag circuit. It's nothing but concept of series resonance. I'm bringing it in another way. Now let's write the voltage triangle. VRMS. This will be VR1, VR2. This phase angle. Do we know this phase angle? Pi by 4. Is it justified? And current I2 will be in the direction of VR2. So just extend this arrow. This I2, you write it. Current in fact lags the applied voltage. And then impedance triangle, you draw it. Z2. XL2, XC2. The resistance is same. And this angle we know. What to do now? That omega 2 has to be brought into the picture. We know VRMS, we know R, we know L, XC, that one, but we don't know I2. But we know RLC from the previous background I put it. And on the other side, we have this phase angle.
18 to 10 to the power of 5.
18 to 10 to the power of 5. Huh? Yeah. Okay, this much of mathematics is what we can. This much of mathematics is there. So tan phi 2. I directly go for XL minus XC2 by R. Do we know R? S.
Sir, R
given.
by XL minus XC. Nothing, sir, nothing.
Okay, I think I'm right. Now this you can write omega 2L 1 by omega 2C by R. We know R, we know phase angle, we know L, C. Solve for omega 2, you'll get the required answer. It's a very best problem. What I'm doing, I'm controlling the parameters by varying frequency. I'm not going to disturb RLC. Look at the circuit here now. We didn't change anything. By just controlling the frequency, what happened, I am able to, so by varying frequency, I'm able to control the almost all parameters of circuit. You calculate what is the power dissipated here. Average power dissipated in this case should be equal to VRMS into I1 only, or I1 square R. Come for average power dissipated here. Should be equal to how much? VRMS I2 cos phi 2. We know phase angle, we know VRMS, but we don't know I2. Can we calculate I2? Yes, the total impedance. Impedance, we know it. If we know omega 2, then we can bring the impedance. Otherwise, not possible. So what is the impedance formula? R square plus XL2 whole square minus XC2 whole square. Unless you don't know omega 2, we can't go any other calculations here to conclude here. So by varying frequency, what happens? The average power dissipated changes, the phase angle changes. XL value changes, XC changes, the power dissipation changes. That's for the core idea of this particular AC circuits. Omega to 18 to 10 to power of, I'll check it now, 5. This will be your answer.